talk. Today we have David Adelani, who's at McGill University and in Mila. I look forward, David, to actually seeing you next week in Canada and visiting Mila, even if it's for a day. David Adelani is an assistant professor at the McGill University School of Computer Science, a core academic member at Mila-Quebec AI Institute, and is a Canada CIFAR AI Chair, which is awesome, and a Rado Professor and a Schmidt Sciences AI 2050 Career Fellow. Today, he'll be talking to us about AfriqueLLM and on how data mixing and model architecture impact continued pre-training for African languages. He will speak for about 35 to 40 minutes, and then after that, there will be questions, just for knowing that there's likely a lot of people on this call who in some ways are either building LLMs, evaluating LLMs, or doing other things with LLMs, David. So yeah, over to you.
Yeah, thank you very much for the nice introduction. Can you hear me clearly?
Perfectly.
All right, good. So let me share my screen. So it's good to know that a lot of people are working on evaluation and also model building. So I will touch on also on evaluation a little bit. So sharing my screen, I hope you can see my slides. Okay. So today
yes, we can see your slides.
Good. So today I'm going to be talking about AfriqueLLM. This is our effort to build like or adapt LLM to African languages. And here we kind of, when we tried it, started the project, we faced several issues and we're thinking, what is the best approach? Should you just throw monolingual data in, and should you try to add some other things to the mixture? And how do you evaluate the model if you don't do post-training? And there are so many questions about which architecture to use. So we decided to just like put everything in the title, how data mixing and model architecture impact continuous pre-training, which I see as a practical way of extending LLM to many other languages. So I'm going to start with the same story you have heard many times, because I know Professor Vukos's lab works a lot on African languages. So I will still start with some motivation why I'm interested in this. You probably know that African languages, there are over 2,000 languages in Africa, and they are very diverse. So I don't need to convince you a lot because you understand the problem. You know, we have several linguistic families in Africa. And near South Africa, you probably have a lot of things going on. You have Indonesia, Indo-European, you have the Khoisan group, you have the Niger-Congo Bantu group, and you have Australasia very close in terms of Madagascar. But one of the things that really encouraged me to work on African languages is this small plot from Ethnologue. And the reason is because we have so many speakers of these African languages. So I find it quite interesting to work on, because actually addressing the problem means you can serve many speakers. So on average, an African language is spoken very closely to like European languages. So if you have lived in Europe before, you will know that most people are multilingual. So if you live in Netherlands, you probably speak English or speak another language, maybe French. And if you're in Germany, you're also bordering with France. So people tend to be easily multilingual. But we also have the same effect in Africa, where people, their native language, for example, if you pick someone in Kenya, the native language can be Kamba, and then the person also speaks Swahili, and this person speaks English. So we have very similar situation. So this plot is not surprising. But despite all these kind of things going on in Africa, the large population speaking the languages, and also the linguistic families, so there are a lot of interesting research we can do on African languages. They are still underrepresented in research. And number one reason is lack of data sets, so which many people have been tackling, especially organizations like Masakhane, and also limited coverage in multilingual language models. But there are also issues about weak language policies. because there's an aspect of policy that is important. If we don't prioritize our languages, I don't think anybody would do that for us. So we also need to have policies that actually encourage people to learn this language, to use this language in business, in education, and in other areas. And the big elephant in the room is lack of compute, because if there's no compute, it's really difficult. The reason why we're able to build AfriqueLLM is because we have access to Compute Canada that actually could provide us a couple of H100. So many African labs may also not have this level of compute to even be able to train a very, like the desired model they have in mind. So today I'm going to focus on lack of challenging benchmarks. A lot of data sets have been created on the African continent. For example, I was part of the efforts to create like Masakhane, which is very impactful. But some of these benchmarks are not very relevant in evaluating the progress of LLMs. So and that's why we had another challenge when we started dealing with evaluation of LLMs, which is lack of challenging benchmarks. And our approach is the following. So I was thinking about this problem when ChatGPT came out, because I was supposed to create another benchmark. And it's so I was discussing with many people at UCL, with my mentor Pontus and several other people, what is the most impactful benchmark to create? Suppose you have $2,000 per language. What is the most impactful benchmark to create in the age of LLM? So I'm going to tell you our solution to that. And the second thing is limited coverage in multilingual representation of language models. And this is going to be the subject of my talk today, which is language adaptation through continued pre-training. So to address the first problem, we had this paper called Iroco Bench. So Iroco Bench is Iroco Bench is our effort to answer the problem, to see how can we tackle this lack of challenging benchmarks problem, right? So, and suppose you have like a minimum amount of data, money, like a budget of $2,000. What is the most impactful data set you can create? And our answer is Iroco Bench. And the community also kind of rewarded our efforts. We got an outstanding paper award at NACU for this benchmark. So, and the major challenge is there have been a lot of evaluation going on. So there's this project with Microsoft called Mega and Megavast, where they try to evaluate several LLMs, like leading LLMs like GPT-4, GPT 3.5 on several languages, but they only include few African languages. And existing benchmarks are not very challenging. So name entity recognition, apart from dealing with tokens, which is already a big problem with LLMs, the task is not very challenging itself. And then also sentence classification, like topic classification, including some of the old problems we have been working on NLP, like machine translation, seems to be not very challenging with LLMs. So I have a plot which kind of clarifies this. So we created SIB 200 in 2023. And the idea was, let's evaluate, it's a new benchmark. So let's evaluate how good are LLMs on this benchmark. So you see for GPT 3.5, we achieved 59.1. And then let's say like 6 months after, or less than a year after GPT 4.0, GPT 4.0 was released. And then you can see the huge improvements. So it's more than, let's say, 25 points improvement. And then you will be wondering, like, oh, what's going on here? So that means you can easily conclude, and this performance is very close to what you have in English language. You can easily conclude that, oh, the LLMs are doing great for these African languages. But it's because you're just evaluating on a not so difficult task. The same thing for machine translation. You see the performance of translation models just improve more than double in terms of performance as we move to GPT 3.5 to GPT 4. So it's easy to conclude that there's a lot of progress on African languages just by evaluating on some of these benchmarks. So this actually implies that we need more challenging benchmarks. And if you compare to higher resource languages, they are evaluating on a completely different task. So they are evaluating on MMLU. So quite knowledge intensive. They're also evaluating on reasoning tasks like math, code reasoning, and we do not have benchmarks for this task. So, and if you look at leading releases of closed models, like the cloud model, when they released it, so they were actually evaluating on things like MMLU, GPQA, and most benchmarks that are multilingual, like the multilingual math reasoning, they only cover one language, which is the favorite for most people, like to just speak Swahili as a representative for African languages. But the performance of Swahili doesn't tell you anything about what will happen if you evaluate on Zulu or let's say Sesotho or let's say Yoruba or Hausa. It doesn't tell you so much because it's actually, we can even say it's like a mid-resource language. It has more resources on the internet. So, leading LLMs providers are evaluating on more challenging tasks. And the last one here is the Bloom project. They are also evaluating on XNLI. So nobody was interested in evaluating on text classification and also machine translation that much. So we created Iroco Bench that actually tries to target really challenging tasks. The first one is math reasoning. So many of you are here as CS students. So if I give you like a minute to solve the first problem, you'll be able to solve it very quickly. So this is like an elementary math problem. James decides to run 3 sprints 3 times a week. He runs 60 meters each sprint. How many total meters does he run in a week? So I think for a good math student, we'll be able to solve this, even in primary school or secondary school in many African countries. But can the LLM do that? And can they reason in native African languages? And the second question is, the second task is MMLU, where like if you have a knowledge intensive task, like which of the following countries generated the most total energy from solar sources? So that means you have to have this knowledge in the parameters of the model to be able to answer the question correctly. Right. So, and then the last one, we have just linguistic relationship. You have 2 sentences and you want to know if it's a contradiction, is an entailment, or not sure. We call this Iroco Bench because we're very confident that this will be a very hard benchmark. But after 2 years or 3 years, I'm not sure it's that hard. So Iroco seems to be one of the strongest trees in West Africa. But now, with the way the models are improving in performance, the benchmark is still difficult, but now LLMs have improved a lot, even on these so-called challenging benchmarks. So how did we create it? So the problem is that, remember, we have like $2,000 per language. So how can we create like impactful data sets with just $2,000? So the first thing is that we have MMLU. MMLU has 57 subjects. If we try to translate everything in MMLU, we are done with our budget. So it's not going to be enough. So we decided to just take like subjects that are not very cultural sensitive and also easy to translate and sometimes international. So we prioritize like elementary math, global facts, high school geography, high school microeconomics, and international law, right? So, and also we could not even translate everything. So we kind of prioritize having at least 500 examples together on all the subjects per language. So XNLI, we decided to downsample. Instead of translating 7,500 examples, so we translated for all the domains, but we only translated 1,000 examples. And the last one is MGSM. So it's actually a small data set, so we just decided to translate everything. So in terms of LLMs evaluated, we evaluated like Cloud Opus, Gemini 1.5 Pro, and a bunch of like GPT models. And also we evaluated some open models. So in terms of evaluation, we did 0-shot evaluation, translate test, and some few-shot evaluation. And we ensure that we have like diverse prompts in the evaluation, and we only display the result for the best prompts per model. So I'm just going to show you 2 main results. The first one is that you will see that like open models struggle with challenging tasks, especially math reasoning. And this is one of the things we actually set up to solve with the AfriqueLLM. So you see that some of the best model that we had then was Aya 101, the open model, Llama 3.1, and Gemma 227B. And they have less than 30 points. on math reasoning for African languages. So MMLU is the second most difficult, and of course, SNLI was slightly easier. So, but the interesting thing we saw for math reasoning is that the amount of monolingual data on the web also kind of predict the performance. For example, English, if you analyze MATLAB tokens, you'll find that you have like very good results for English because it has more tokens on the web, so the model can understand the queries better. And then you see as the number of tokens reduces, you also find worse performance across different languages. For example, Wolof was just 28 for GPT-4. So in summary, I mean, I could tell you more about Iroco Bench, but this is not a focus of today's talk. But I have to highlight the evaluation challenges so you can appreciate why we decided to actually attempt the Afrique project. And one of the things is that we first need to create like a challenging benchmark before we can build a model. And that's the only way we can measure progress. And we need to go beyond like simple classification tasks or machine translation to be able to make improvements on really challenging benchmarks. And as you can see, there's a large performance gap between high resource languages and African languages. And the gap is much wider for open models than proprietary models. So we did another project by my master's student, which I think she already finished a master's now, so Afrobench. And we try to scale all the evaluation to many tasks, but the performance is very similar. So Iroco Bench actually kind of already captures the same thing you will see in Afrobench, where you see the proprietary models are on top, and then some stronger open models are in the middle. And also we had a lighter version where we also face this challenge because when we were running evaluation for Afrobench, it took us more than 3 months. 3 students were running this experiment, and it still took us more than 3 months to finish the experiment on several GPUs. And we also even used some API credits online. So it just takes a lot of work. So we decided to introduce Afrobench Lite, so where you do not have to evaluate on the same thing to have the same findings. So here we prioritize just 14 diverse set of languages, 7 data sets, 7 tasks, ensuring that we do have those challenging tasks like MMLU, math reasoning, and also some QA data set, including machine translation and SID. And then you can see that, like the later, like the newer models often have better performance. You can see the performance of GPT-5. That was in August last year. And then if you compare to GPT-4 or a year before, you will see that there's a huge jump in performance, more than 10 points on average. So, but having Afrobench is also important in building an AfriqueLLM because now we have an evaluation benchmark that we can test on, and we can also measure progress based on Afrobench Lite. So, but one thing we did for the AfriqueLLM is that we, instead of just focusing on 14 languages, we actually do evaluate on all the languages that are available in the data set. So just to tell you that. So for the second part, which is also the reason why I was invited, the basic thing we did was just continue pre-training. So the idea is very simple. We take a model that's already been fully trained, and then we continue to train it on new set of languages. And it's very simple as that. But just doing that on monolingual data may not be the right approach. So here we're investigating what kind of data should you mix in the pre-training? What kind of data do you need for, let's say, mid-training or post-training, and so on. So this was done by my master's student that has also graduated for developing an African version of LLM. So another motivation why we had to do this, again, African languages are underrepresented. For example, if you look at the amount of models you find on Hugging Face, Chinese models, we have over 8,000 Chinese models, but Swahili, even the largest most spoken language in Africa, only has like 345 text generation models. So in terms of even the models created for these languages, many African languages are also underrepresented. One practical way of actually changing this or improving this is what is called continuous retraining. So you just do language adaptation to a new language. You do adaptation to a new language or to a new domain. So, but what we found out is that naive application for low resource languages does not improve performance on challenging tasks. So, actually, the first effort to do this was with Api Buzaba, so at Princeton, where we had an effort was just to do continuous pre-training with Llama models, and we had improvements. So, but the problem is that we only had the largest improvement was for XNLI. So, which is a language understanding task. Well, we're not able to improve at all for maths reasoning. So, for example, you can move from 3% to 4%, or you move from 11 to 12. So, that means just doing continuous pre-training on monolingual data doesn't solve this problem for you. So, we need to really look at what kind of data goes into the continuous pre-training and what is the model you decide to adapt. Should you adapt Gemma instead of Llama? Or should you just maybe pick a Chinese model, Qwen, for adaptation? So we released AfriqueLLM, covering 20 African languages for the first initial version. And then we cover we released several sizes of the model, 4B, 8B. I think we also have 12B for Gemma and 14B. And currently we have over 5,000 downloads on Hugging Face. That's nice that the community are using it. So we are very grateful for that. So in terms of what is in the data, it's very simple. Everything here is on the web, maybe except the last part. So we have monolingual data that was collected from FineWeb 2. FineWeb 2 is an effort by Hugging Face to kind of have clean data across many languages. Because most of the common core data, if you work on common core data, you'll find that they're very noisy. So we decided to use that. And also Wura was our effort with the University of Waterloo to actually create a high quality data from multilingual CIFAR. And actually this requires a lot of human verification. So it's really, really high quality. And also we combine it with Google's effort to also create a cleaner corpus called MATLAB 400. So we also added parallel data from NLLB. If you have worked with NLLB data before, you know that it's also very noisy, but we also included it in the pre-training. Additionally, we have seen a lot of efforts. For example, if you have seen this paper from Hugging Face, it's called Small LLM. So they also try to include naturally appearing logical corpus. That's the way we will put it. So like maths, code. So this kind of forces the model to reason based on this logical things in the corpus. So we decided to go for math and code. And lastly, because African data are often kind of biased to some few domains, especially religious text or news articles, we decided to translate by using what is called Web Organizer. So Web Organizer is like a classification task on the web. So someone performed an automatic classification of all common core data and split it into different categories. So you have things on economics, you have things on business, you have things on education, and then we can select very diverse domains to add into our corpus. But the only way we can include them is by machine translating them. So we use GPT 4.1 that is very decent in many languages to translate. And of course, some portion of it are also noisy. And then we added it to our pre-training. So in terms of training and evaluation, so we added some high resource languages, English, French, Portuguese, and Arabic. They are also widely spoken on the African continent in many African countries. So we, for African languages, actually, we chose 20 most resource languages. Here, I have actually added the high resource. That's why I have 24. And then we did what is called Unimax. It's an algorithm that was added for for creating UMT5 model at ICLR 2023. And the idea is to reduce unfairness in data size. For example, you can have, looking at the data here, you see that, okay, English has more than 1 billion tokens, French has, Portuguese, Arabic have more than 1 billion tokens. So, and then Africans, Swahili, Moroccan Arabic, and Somali also have more than 1 billion tokens. But the other African languages, after combining data, they have less than 1 billion tokens. So how can we reduce this unfairness across that? So we want everything to be, if possible, near 1 billion tokens. So what we did was to sample some other languages more than one time. So for example, Amharic, we kind of sample a bit more. Hausa, we sample like twice more. So if you have 500 MB, MB of data, so now you have you have 500 million data, and then you sample it twice more, so you have like 1 billion of data. So we did the same thing, and for some lower resource languages like Yoruba, we had to sample them like 4 times. So to kind of reduce the unfairness in the data. And the other thing we did was to translate using the web organizer corpus into many African languages. Additionally, we added code and math and parallel data from LLM. So we called our data mixture the following. Everything has monolingual data, but if we have added code and math, we call it CM data mixture. When we added synthetic data from web organizer, we call it CMS. And when we have added parallel data, we call it CMSP for all the 24 languages string. So we train using what is called Llama Factory, which also allows continued pre-training. We evaluated on Afrobench, which I described previously. And then we try to evaluate on also very challenging tasks like MGSM and MMLU, and language understanding tasks like NLI, in Django, Bele, SIP 200, and Flores. So the first question, the data mixture do matter. So like, for example, if you only do continued pre-training on Gemma 3-4 billion, you see that you improve quite a bit, a lot. You even more than double performance for Flores, just monolingual data. The same thing for XNLR, you improve by 7 points. So this we already know, even from Luga Llama project that I was talking about. But for challenging tasks like AfriM GSM, the performance doesn't really change much. So you only move by 1 point. So MMLU, you move by just 2 points. So when we try to add code and maths to the monolingual data, what do you find? You see that now the Flores performance stays the same. The code and maths are in English, of course. So, but you find out that we have more than 4 points improvement in performance for maths over the monolingual data. Suddenly, we also improve slightly for MMLU. So we added parallel data into the mixture, and we, of course, improve for Flores because now parallel data is supposed to help translation tasks, but it doesn't really hurt the performance of math reasoning, and it doesn't really hurt the performance of XNLI, but it does seem to hurt the performance of MMLU. And the last one was we added just synthetic data, and you see that we had the best result for MGSM. So we added parallel data into the mixture, and of course, it does improve performance for Flores again and MMLU. So, okay, I think someone is drawing something, but yeah. But if we increase the data size, sorry, the parameter size of the model, you will see that we have very consistent findings. So monolingual data is already enough for Flores, it's also already enough for XNLI. But if you had parallel data into the mixture, it does not really, it does improve MGSM, surprisingly, but it hurt the performance of XLLI. But when you look at the mixture of code, math, and synthetic data, we have some of the most consistent improvements, both on the small model size 4B and 12 billion. So for example, for code, math, and synthetic data, we consistently improve for Flores, we consistently improve for Math reasoning, we kind of improve for MMAU, even though we don't exceed the pre-trained version. I think MMAU is just more difficult to improve over. And then we also improve over X and LI. So eventually we just selected code, math, and statistics data as our data mixture. That was the best we could do there. Okay. And after a while, because we don't have infinite compute, so we kind of stop our exploration after this. And then we now decided to see what is the, is there a way to remove this? I don't know, but what is the best way to change, what model rather should you do continued pre-training on? So we explore Llama 3.1, Gemma, and Qwen. And one thing you will see is that Qwen performance is worse because they have not really trained on African languages. But once you do continue pre-training, there was huge improvement in performance, really huge improvement in performance for the Qwen models. They are improving more than 20 points, and the performance improves also by the model size you have used. If you use 4B or 8 billion, actually we got the largest improvement with 8 billion model. It was like the perfect size model we could test. But another interesting thing you could find here is that the strong model prior, for example, Gemma is very multilingual. When you do continued pre-training, the improvement is only a little. So for example, you have Gemma 312 billion, it only improves by 4 points. But if you start with a Qwen 314 billion with 40 points initially, it jumps more than 20 points. So that means even if you have a well-trained multilingual model and you want to do continued pre-training, that doesn't guarantee that it's going to give you the best output. So you need to actually explore. And in our case, we find the Qwen model actually giving the best performance. So this is the evaluation on all the tasks. So I just gave you an average. And you see on one of our priority tasks like MGSM, why we did this, we found out that we could improve. Llama was just 9 points because we didn't add other interesting things to the data mixture. And you see that but by adding code math into the data mixture, you already improve performance for even Luga for Llama model by an additional 9 points. Okay. And you see that we improve also for Gemma, but the largest improvement also comes for the Qwen model. And the improvement was huge. It's like we more than double the performance, going from 16 points to like 45 for the math reason. And this performance is better than what we obtained for GPT-4o like 2 years ago when we were working on Iroco Bench baseline. So I think this is really impressive. Consistently, we improve for Flores in Django and all that. But we found out that Gemma model, just because it was more multilingual at the beginning, actually gave it an edge on translation tasks. So if you're working on translation, maybe you should still use Gemma model. But if you care more about reasoning, maybe you should consider, for example, Qwen model. So I'm just checking my time. I think I will try to wrap up in 4 minutes. So in terms of language-wise gain and loss, languages that are pre-trained, if they are high-resource languages, you might have some negative interference. So for example, performance of English and French will probably degrade a bit for some models. For the African languages we have pre-trained on, the performance always improves. Why for the African languages we have not pre-trained on, the result is mixed. Sometimes it transfers, sometimes it doesn't transfer very much, depending on the model. So this is the average performance on different languages. And you see across all the languages from Amharic, Hausa, Igbo to, let's say, Sesotho, Xhosa, Zulu, you see there's huge improvement in performance. But you find out that for Swahili, actually, we had like a negative, like it doesn't really improve for Swahili. So that means Gemma model actually is well-tuned for Swahili, and it doesn't benefit so much from our continued pre-training. But if you use like the Qwen model that has not seen Swahili that much, you will see that also, actually, Qwen model has seen some Swahili, but not a lot. But you find that also the Qwen model do benefit a lot from Swahili. But you see that the effect that Swahili had in terms of increase in performance for the Qwen 8 billion, it's only at 20, while for the other languages it's more than 25. So being exposed to the language like initially might reduce the kind of improvements you will get when you do continual pre-training. So we also extend this to document translation. So document translation, document level machine translation is a challenging task, and many of the SOTA models are sentence level based. So here we also try to see that, let's see what is the performance of a new model, because our model actually has a bigger context window, let's say 128K. So we could do few short experiments. So we use the AfriDoc MT by Just Jobalabi to actually do this experiment. So the AfriDoc has like 5 African languages, and they were segmented into 10 sentences per document. And what you can see here is that if we just do few short experiments, this is just 3 short experiments, you see that we are actually better than their previous baseline when they have performed SFT. So SFT on the translation task normally should give the best result. However, without SFT, you see that the performance is very low, 17.9, but with SFT, it jumps to 47.8. But with our model, like the AfriqueLLM, AfriGemma, and AfriQuen, you see that we consistently improve performance just with 3 examples. So 3 document level examples. So that was quite impressive. Lastly, we're really concerned about, okay, what is the effect of using a better multilingual model? So while our paper was accepted, also at the same time, Qwen 3.5 was released, and surprisingly, it covers more languages than the one we have used. So 3.5 covers 201 languages, Qwen 3 covers 109 languages. So we decided to do the same experiment. So, and the interesting thing you can find is that we have very similar performance, but however, because Qwen 3.5 is more multilingual, the improvement in performance slightly drops. So initially for Qwen 3, we improved by 23.4, and now because Qwen 3.5 is more multilingual, we only improved by 11 points. But interestingly, we still kind of improve more than Qwen 3, more than Qwen 3 after continued pre-training. So AfriQuen 3.5 actually is a better model than AfriQuen 3 4B. So another thing we find is that actually we are not able to improve over math reasoning. Surprisingly, we had better performance on AfriQuen 4 billion than AfriQuen 3.54 billion. So to address that, what we did was to extend the number of tokens in our pre-training. So we increased the number of math tokens and code tokens by 5 billion. And then you see that we're able to recover the performance that we have lost in the initial AfriQuen 3.5. So lastly, we decided to scale to 50 languages. It's quite ambitious, but we decided to do that. And what we have found is that even just training, like adding tokens from those lower resource languages, after we have balanced and improved math and code tokens, added more, it doesn't really hurt the performance. So there's no reason to just scale down to 20 languages. So we find that actually scaling to 50 languages also works quite pretty well for the tail languages. And we find that languages like Lingala, Wolof, Ewe that were not initially added actually add also improvement in performance. So just adding math or code tokens doesn't help you improve over very low resource languages, but really exposing the model to those new languages leads to better performance for the tail languages. So this is what we have done. And of course, our aim is to extend continuous pre-training model to larger models of Qwen 3.5 if we have the compute. Now we don't. And now currently we're doing SFT and post-training and GRPO post-training for the model. And we are getting some very good early results. And we're also working on safety alignment. So we just created a new benchmark for safety called Tuka Bench. And the next step of the project will be to also improve safety for AfriqueLLM. Thank you. And so you can find the model and the code and the paper here. And thank you very much.
Okay. Thank you so much, David. I think that was a tour de force. There's a lot of things that had to go into that space, and thanks also for, I think, for the some of the what's this? Sorry, words. Today has been a long day. It's been PhD and MSc progress update day, so we didn't Zoom this is like early in the morning. Like tips on what you guys were able to kind of see, and then where things kind of worked out or didn't work out. Like maybe some thoughts in this case, especially hitting that compute bottleneck in terms of continuing, in terms of other directions that people could be thinking about in these areas, right? I think you've highlighted some of the stuff being not necessarily just the SFTs, but then also the evaluations that people should be building. But what are other things in that area? And then we are also looking, for example, in general across different spaces at things like SLMs for specific use cases, so not general generative AI spaces. So that might be good. And with that, yeah, if people have questions, please raise your hand. I'll acknowledge you while David answers my first comments in this area.
Yeah, thank you for the question. I mean, the compute is a big bottleneck. Like, it took us several months, like more than 6 months, to even carry out this continuous retraining. For example, we use Slum, and you can only run experiment for 24 hours and it will stop, and then you have to queue. Maybe you will get a server like in another 7 days or in another 3 days. So it just takes some time. So this is a challenge, but one thing we have found out, especially if you're interested in SLM, you can actually even go lower in terms of the model size. So for example, most of our initial experiments, we did it for 4 billion model, because we can actually get some quick insight very quickly from the smaller model size. So we can also do exactly the same experiment on 0.6 model, on 1 billion model, to know what is the right what is the right data mixture, what is the right thing for that domain you're interested in. And then we can now scale continuous pre-training and targeted SFT, for example, for that domain. I think this might be the future. I believe like SLMs is actually the future, because people probably at some point don't want to pay credits, API credits to these companies, and they will want to have like a model that just works very well, maybe for finance or for their use case. And I think there's a lot of opportunity in that area.
Thanks. Let's say Casper, quickly. Let's keep it short, because I have a feeling more and more questions will come in, and then Ayodele. Can you just both ask your questions one after the other? Casper?
Okay, my question is with regards to the choice of the model. You mentioned that Gemma seems to perform quite well on African languages. So what do you recommend with regards to picking a model? Does it mean we should avoid Gemma, or what does that mean? Thank you.
Okay, quickly, and then Ayodele, can you ask your question, please?
All right, thank you very much. Thank you, David, Professor David. That was a very good and informative presentation. I would like to ask, on page 23, you gave a particular evaluation table, and then it was Flores there was actually performing well. Then I'm just asking, or my question is, which direction, which translation direction was this evaluation for Flores? And also, I didn't pick the page now where you talked about Qwen performing well, for the continual pre-training. And then I'm just curious, why do you think, in your opinion, Qwen is better, even though it was not pre-trained on any African language, and yet it's better than models that are being pre-trained on African language while doing the continual pre-training? Thank you very much.
Right. Okay, great questions. Let me quickly answer the first two. I think they are connected. I didn't say don't use Gemma, right? For example, every LLM providers really want you to use their model, like Llama, Gemma, and Qwen. But we're just saying that to get the best improvement in performance, don't restrict yourself to one model. So if your goal is to get better performance, you should try the same experiments on other models. Some people, for example, Llama has been the favorite of many people because it was the first model that came out. But some people don't pay attention to that. Okay, there's an alternative. There's a Gemma. For example, there's a Qwen, right? For example, we didn't want to use Qwen initially, but because we are submitting to a top conference, we find that it's important to really try diverse models. If not, our paper will probably be rejected. So, and then it's come as a shocking to us that the like Qwen model gave better results. But one quick explanation we found, which we also saw for the Afrique 3.5, is that if your model has seen a lot of those languages before, it's more difficult to improve over, right? So if you, for example, the AfriQuine 3.5 that covers more African languages, you will see that the gap, the improvement we saw was way less than AfriQuine 3, right? So Qwen 3 and Qwen 3.5, we had less improvement in performance because Qwen 3.5 has seen more languages, including many African languages, so the improvement is smaller. So this is the same thing we saw for Gemma models. But another thing is that we also find that Qwen, it's easier to adapt the model. It's just that maybe it's a better model and there's no better way of saying it. I think it's just a better model and adapts faster than like Gemma 3. Maybe if you have tried Gemma 4, which we didn't try, maybe you're going to get the opposite effect. Then you find out, okay, maybe Gemma 4 is not a better model than Qwen. But it's something that we need to explore because we are not the designer of the models, and most of the details are not out because they don't release everything that goes into the pre-training these days. So we have to kind of try multiple things to arrive at what is the best model. In terms of Flores, we prioritize translation into African languages, and that's why the numbers are a little bit lower. And the evaluation here is SSC comment, which we find to be more reliable than, for example, CHRF. Okay, thank you. So,
okay, thank you. Idris and then Soga.
Okay, thank you, Prof. Thank you, Professor Adelani. Okay, sorry. And I hope you returned safely to Canada. So my questions are twofold, but more or less like related. On evaluation using translated benchmarks, and then how valid those performances can be set, maybe can be reported or even relied upon. Because in a way, we are trying to take LLMs, train on noisy data, in some instances synthetic data, and then evaluating them on synthetic data. So like what will your comment be that? So also, is there like, or are there existing in the wild benchmark creation that will enable evaluating the actual deployment usage of these models? One. Secondly, so say I have, say, maybe $200,000 of credit. Is it worth it to do actual CPT on using the existing resources that you know, but also I think the comment between the small language models and the LLMs and the rest, is it better for me to, or for a person particularly, to focus on training a better maybe sequence to sequence model or expert models rather than a generic LLM? Yeah. Thank you. You are muted.
Okay.
excellent
And quick
question.
one.
Okay, yeah.
Oh, okay, it's a lot of questions. Okay, go ahead, David.
So it's because I'm going to forget.
Yeah.
Hopefully you also arrived safe. We met in ACL in San Diego. And thank you for asking those questions. So one thing I want to clarify is that the translations are not synthetic generated. All this, like I had a human translation. So MGS, MMLU, XNLI are human translation. In Django was actually created from scratch. So it was generated, not human. Sorry, not even translation. To clarify that. Of course, there's also the effect of translation is that if you do human translation, it's not exactly the same thing as human authored benchmark. That is probably one of the limitations of our work, and it also shows that there's more work to do in terms of creating more realistic benchmarks for African languages. So on the second point, I mean, continued pre-training, there's a lot of things we can learn from continued pre-training, but it's just very expensive and it takes more time. Depending on your compute situation, I would say you can do SFT. So there's a lot of interesting recipe also for SFT, and that's what we're exploring now. So I would be really encouraged if people like start off with the AfriQuoin model or the AfriGemma and try different SFT strategies or reinforcement learning, which is also quite expensive, to see if they can even improve further for a particular task. We had one successful thing with math reasoning where we picked AfriQuoin and we did GRPO on top, and then we had very impressive performance. Like we had huge improvements for Swahili, I think from going from 40s to over 70s. So I think those are like new experiments that we can carry out, even if we don't, for example, have a lot of compute. All right, so next questions. I hope I answered all the questions correctly. But...
Okay, Soga, let's go quickly.
Yeah, thank you, Prof. My question in almost 3 parts. Kindly indulge me on this. So what qualitative inferences can we make from your findings? First, in the respect of diverse data, are we fairly concluding, based on what you're telling us, that you can effectively achieve leadership in terms of compute by having more diverse data? So is your leadership contingent on diverse data? Then in terms of mode of extraction, you were talking about some universities and other institutions you work with. What's the mode of extraction? Do you subject yourself to the internal mechanisms or laws within those territories, and who owns that data? Then the final one would be about the relationship between the budget you were talking about, I'm sure that's finance, and the data itself. Is there a direct bearing between the finance, the capital used to extract the data, and can that be recycled? Say, if that data is owned locally, indigenously in some of these territories you're talking about, can it be recycled to another space for generating increased performance? So these are some of the questions that I want to find some answers to. Thank you.
Thank you. Okay.
Yeah, sorry. Samsung, I'd asked to change. I don't know who you are, but then can you ask your question quickly? I'm sorry, David. This is the only way.
Yeah.
We can do a round 2 when I know you've got a V2 coming along soon. So we'll ask you to come back very soon as that comes out as well. Samsung?
Thank you.
Yeah.
This is Rosa from Ethiopia. This is Rosa from Ethiopia. It's a really great work. I really appreciate. One of our challenges in Ethiopia was that we can't use these LLMs, existing LLMs, because they don't have our language properly. So it's a really good finding. But my concern is now we have the AfriqueLLM. Can we use this LLM for Africa? Because one of our challenges is infrastructure, let alone having a model with a parameter 4 billion and 12 billion. Our infrastructure can't handle 1 billion parameter of model. So how about like providing our solutions on the reality? You know, now I didn't see in your future work also what kind of solution that we can provide or suggest, or what kind of strategy that we can come up with for the small size LLMs, so that we can properly use these LLMs for different applications in Africa in different domains. Thank you very much. I would like to hear your saying on this. Okay,
go ahead, David.
Quickly on data, so all the data we used are kind of open source, so you can find them on the web organic. So the only one that we didn't open source, because we're also unsure if we can, is translating or some articles using GPT 4.1. So we have not open sourced that because maybe OpenAI would not be happy that we release some synthetic data from their model. So, but the other kind of data that we generated, we have completely open source the data, so anybody can use it. So in terms of, we don't need to collect permission because it's kind of public already. with very, I mean, the license is clear that we can use it. So if we have some restricted data, of course, we have to get permission for the data. So the thing about, I think there's another question which I've completely forgot now. So
about the Ethiopian languages and then the use of your models.
Yeah, the Ethiopian languages, definitely. And actually, I remember now that we did create something smaller for 4 billion that we didn't release. So I'm probably going to talk to my students after this that we probably release the 0.6 or 1 billion model. That if people are interested in this, they can also use it for maybe simpler tasks. So I think we should release smaller models. Like I just didn't know why we didn't release it, but thank you for raising that point. So I think it's
before Dr. Jabera comes in, please let's have a chat on email about the synthetic data with OpenAI. I believe you're protected, or we believe you're protected, meaning we can bring in our legal scholars into that space. So please, anytime anybody on this call, if you ever in a situation where it's a legal issue, please do contact us. We have a separate set of people we collaborate with who can then work with you to understand, especially which country you're from and what you could be doing. I'm being very serious. Do not take it lightly. We do want to create as many African resources as possible, and sometimes I think it's more we're thinking that we are blocked, but then actually we might not in these areas. So yes, Dr. Jabera.
Yes, thank you so much. And of course, very good presentation. I was just curious to see in Tanzania, Tanzanian Kiswahili is quite different from the rest of the part like Kenya and others. And we are in the way of working towards Kiswahili LLM. And I was just thinking around on what could be the best model that could be recommended apart from AfriQLLM that you have mentioned in its variants. And of course, in terms of benchmarking, you also gave some recommendation. I appreciate for that, and maybe I could hear much on that. Thank you.
Yeah, thank you. I think it's a very important effort to have Swahili that works better for Tanzania. I mean, we have faced this problem before. Like we were trying to develop SSA Comet. So we got the text from Kenya. I think they used the Kenya Swahili. We got the annotators from Tanzania, and there was like a lot of things going on. So eventually we are not even able to get a very good annotation. So I think there are interesting differences between these two dialects. And I think, but it's also an easier problem because it's also an easier problem, but also challenging because they're similar. So that means we can easily adapt the model quickly to Tanzania, but it's also a challenging problem because there's a lot of language confusion, which is another problem with LLMs, that when you ask them in Tanzanian dialect, they will just give a Kenyan dialect. So I think it's a really important problem you're trying to solve. If you have enough tokens that can also show the LLM the differences between, for example, Swahili dialect and the Kenyan dialect. Yeah.
And maybe on follow-up, sorry for that. And I know it has been a challenge because we know people are coming up with web scrapping, and sometimes the discussion that is in the, of course, I was appointed by the minister to sit on the Kiswahili board in Tanzania. And one of the discussion that we normally discuss is we have now starting seeing new terminology coming up from most of current LLM, but which are not verified, are not standard terminology in our language. And so we feel like maybe dilution of language is coming up. Maybe I'm not quite sure on how we can solve this, but this is something that we are also thinking around. Thank you.
Okay.
Thank you. Sogan, go ahead quickly. And then Adewiyo, you'll be the last one. And as I said, I'm sorry, we're going to go over by 5 minutes. This is not, we typically try to stay within. So Soga, quickly.
Yeah. I was just drawing attention to my question on computer leadership and diverse data. and also the regenerative ability of the budget you use for generating data. Yes, those were two parts of my questions.
So in terms of compute, I'm just replying also in the chat. It's Canadian-wide infrastructure. Every Canadian PI, like professor, have access to it. And then we have some allocation. So in terms of the compute, we got some OpenAI credits. And actually, we got some other credit from Microsoft, which allows us to actually be able to translate a lot of, like, I think we translate like 10,000 documents into various languages. So we got some generous like compute offers from Microsoft that allows us to do this translation. And that's one of the reasons they were also part of this paper. Yeah, thank you.
Okay. Unfortunately, I'm going to have to use Adawi. Can you please, and Mahmoud, can you please put your questions in the chat? And then what will happen is that I'll ask David to kind of try to respond to them, and then we'll send it through an email update when we announce that the video is online. We can't, as I said, like we could go on for very long. And then on top of that, yes, I think one highlight for people is that, remember, if you're at a university, for most of the world, we know that there might be places that are limited. You can apply for compute credit grants, especially in places like GCP. Microsoft tends to also have sometimes, and you do have a number of also the big tech also out of China now, especially trying to get you to try out Qwen for some of these things, also providing compute that is connected to this. So please do use those resources and then try out. There's no necessarily right way or wrong way. There was a question, sorry, quickly, David, to put up that slide with the QR codes, and then if you can also just paste the links maybe directly into the chat as well. Sorry, I keep on forgetting about that one. Yeah, in this space. So I think it's an important thing. As I say, like for this one, it was a bit different to most of us because we know a lot of you are building, and that's why we wanted to have David over. We will probably have a few more. I think in the next one, we're going to try and talk to, is it Apritas, which is the Swiss kind of, probably we've gone AI Singapore. We're now in Canada with AfriqueLLM. Now we're going to go to Switzerland, and we'll keep on trying to bring in more people in these spaces to share. And we're hoping that you're also, as you're building whatever that you're building, you can please reach out to these different teams and really engage on these. There's going to be lots of discussions, debates in these spaces, and I do hope they keep on growing. And that's the way that we actually get to our language vitality in this space. So thank you everybody for coming. Thank you, David. I look forward to meeting as many people next week at Mila and giving my talk on evaluation. Idris, why are you making this hard? Yes, it is.
Yeah, just a minute. I'm posting something on the chat to invite people to contribute towards our synthetic data validation.
Okay, cool. All right, thank you. Yes, there will be, I think we'll send out an email with a lot of information inside it after this one. So, all right. Thanks, everybody. Enjoy the rest of your day. I also have to jump on too. Okay. Bye, Dave. Bye.
Okay, bye.